In exercise 4F, we're going to be exploring some trig identities. And we're seeing how these trig identities can allow us to eliminate some terms. So, trig, you know, sine, cos and tan, cosec, sec and cot of angles. Identities just means that we've got an expression on one side of an equal sign and it's equal to an expression on the other side. It's an identity saying that these two expressions are identical. The way that we use them is that if this was capital X and we knew for some reason that X was A on B, then anywhere we see an X, if we want to eliminate the X, we can replace it with A on B. So it's not a new concept at all in that you're eliminating items. You're eliminating them now by substituting something else for that term. And again, that's not a new concept. What will be new are the actual identities, what things are equal. So it's based on our new definitions, based on the circle representation, and that we found that sine of theta was the y-ordinate of a point on the circle and cos was the x-ordinate. We also found that tan of theta was y over x. Now we're taking that one step further. If tan of theta is y on x, it stands to reason, since y is sine theta and x is cos theta, that we can write a new identity in that tan theta is sine theta on cos theta. Now, you may have seen this before. By far the majority of questions involving this identity will just be straight out algebra style. So algebraically, you'll be given an expression and you've got to turn it into something else. You will use these identities to replace terms that are given. For example, you can now replace tan in an expression with sine on cos. We'll move on because there are also two other identities. Oh, no, there are more identities. You know that cot theta, because it's the reciprocal of this, which is, I'll just write it as 1 on tan theta, or the reciprocal of that makes it cos theta on sine theta. So you can see that an offshoot of the identity, tan is sine on cos, becomes cot is cos on sine. And so we've got cos on sine. Now, you may be thinking, where are you going to use it? You're just most probably going to use it in show questions. There are applications of it, but for the most, you will just be using it using it algebraically, really, so using it as a substitution so that you can show the left-hand side is equal to the right-hand side of a statement. Now, we could see that originally we had the circle x squared plus y squared is r squared. If we divide through by r squared, and we have, just before I make the connection to the identity, remember that when we were using the radius as r as opposed to 1, then we had that sine of theta was y on r, and cos of theta was x on r. So you can see that x squared on r squared is the square of this situation, which would give us cos squared would be x squared on r squared. So we have that x squared on r squared is our cos squared theta plus y squared on r squared is our sine squared theta, and r squared on r squared is 1. Now more commonly we reverse those two and our new identity becomes sine squared theta plus cos squared theta is 1. Now I guess the variations on this identity are that sine squared, are that sine squared, sorry about all that, that sine squared could be written as, or replaced with, 1 minus cos squared, or also keep in mind, if you see 1 minus cos squared, you could replace it with sine squared. Now, these identities work in both ways. You may even see the number 1 somewhere and think, oh, it'd be more convenient to write it in the format sine squared plus cos squared. You might be introducing more trig terms into a statement in order for you to progress on through a show question, and likewise with the cos. Now, we're going to generate some more identities, and this time we're going to take our new sine squared plus cos squared is 1 and, for example, divide through by sine squared. So, sine squared on sine squared, and cos squared on sine squared, and 1 on sine squared, and simplify those. Sine squared on sine squared is 1 plus cos squared on sine squared. Now, cos squared on sine squared. Where did we see cos on sine? That was back the very first identity, which was cot squared theta is equal to, and 1 on sine, we know that 1 on sine is cosec, and so we've got cosec squared theta. So another identity is this, cosec squared theta is 1 plus cot squared theta. Now it doesn't matter if you write it like this or like this, or if you wrote, how could we vary that? Cosec squared theta minus cot squared theta is also equal to 1. Now please remember, 1 could be now replaced with this, if that's what you are thinking you would like to have in an expression, as opposed to just having a simple 1. If you find you've got the expression 1 plus cot squared, and it's not looking like there's any cot squareds needed, but you do need cosecs in the expression, then replace your 1 plus cot squared with this cosec. And likewise, if you've got a cosec and it's looking like you don't want cosec, but you wouldn't mind having cot in your expression, that would help you progress, then you can replace your cosec squared with 1 plus cot squared. Now, this is just basically what you're going to be doing with these identities. I'll just check on the reference sheet that these identities, whether they're given or not. So as you can see here, this is the reference sheet. The one that is given is the sine squared plus cos squared equals 1. Now, you will see that just the identity I've introduced you to came from that, and the next identity is going to come from this one as well. So you can always use this to generate the new identities. Remember, the identity that I've just talked about was made by dividing through by sine squared of theta. So going back now to our sine squared plus cos squared equals 1, and divide through this time by cos squared, you can see gives sine squared on cos squared is tan squared, cos squared on cos squared is 1, and 1 on cos squared is sec squared. So I guess that in itself is an identity, or you might also see it written as sec squared is 1 plus tan squared. Now, you don't have to learn it in this format. You don't even have to learn it. You could just go back to your sine squared plus cos squared is 1 and go through the process of dividing through by cos squared to generate that, and then from that you can write it in this format. What else could you write? You could write tan squared theta minus sec squared theta is minus 1. Tan squared, yeah. So look, what you have to be on the lookout for is ways to maybe write minus 1, ways to replace that expression, ways to replace that one, or ways to replace sec squared. So I'll stop the video there and go through the examples in another video.